Hello guys, we want to look at um, three charges placed in a coordinate system. In this case, you'll be surprised that in this question we're going to see another shape entirely, which I want to listen as you do that. God bless you. Please subscribe and ensure you will click the like button if you are just watching my video for the first time. Thank you for those of you that are watching, that are returning viewers. Thank you very much. God bless you. Now let's start. We say three charges Q1 equal to minus 2 microcoulombs 0,0 centimeter. Q2 equal to 4 microcoulombs 0,10 centimeter coordinate. And Q3 equal to minus 3 microcoulombs 15,0 centimeter coordinate. Find the total electric force on the charge at the origin 0,0. Find the magnitude of the total electric force in A above and find the direction or the angle that the total electric force makes with what? With the positive x-axis. Now let's start right away. Let's start with this what particular and their coordinate. Okay, let's draw a what kind of, okay, this is what this is the origin 0,0. Okay, so this is what positive y-axis and this positive x-axis. This negative x-axis and this what negative y-axis. Now let's go. We have minus 2 microcoulomb placed at 0,0 centimeter. That is what minus 2 microcoulombs is here. Okay. Okay. Q2. This is Q1. Don't forget this Q1. Q1. Q2 is what? 4 microcoulombs placed at 0,10. That is x coordinate is 0, y coordinate is 10. That should be along the y coordinate. So this is on the line of the y. So let's say this is what? Plus 4 microcoulombs. And from here to this place will now be what? 10 cm. Then the last is what? Q3 equal to what? Minus 3 microcoulombs. 15,0. X is 15, y is 0. Should be along this axis. Along the axis here. So here is what? 15 cm. So y is what? 0. So in that case, this is what? Minus 3 microcoulombs. This is positive what? X. Now, having done that, we have the positive, we have negative, we have negative. Now, what we're going to have, they said what? Find the total electric force on the charge at origin. So this is the charge at the origin. So we are calculating net force on this. And the net force on this will be the influence of this on this and this on this. So influence of 4 microcoulombs on minus 2 microcoulombs, influence of minus 3 microcoulombs on minus 2 microcoulombs. The two of them together will be operating at what? On this, they will calculate their net force or the total force. Now looking at this is minus, this minus. These two are like charges. Automatically mean the one force will go like this. That means one a force. Don't forget this one is Q3. Why this one is Q2? So this is what? F. Let me clear this one so that we can see. This F 3-1 because it's done by, or let's say 1-3. That means 1 on 3. That means Q. The force of this one on this is this one. Why the force of this one on this will not be what? We repair like this. Why? Like charges repair. So this F of 3 on 1. 3-1. So 3 on 1. Charge Q3 on 1. This is charge Q1 on Q3. That is 1-3. So they are equal if you look at it very well. Now this one is equal to this one, both in opposite direction. We are not concerned about this, mind you. You know why? Because we are calculating net force on Q1. So our concern is about this particular force. That's our concern. We are not concerned about this. So plus and minus charge, they will attract. So this one, what is the influence of this on this? It will make the charge toward move towards it because they attract each other. So I don't need to draw any force of this one on this, because we are looking for the force on this plus 4 microcoulombs on this. What is the effect of minus 3 microcoulombs on this? So this one is what? 4 on 1. Okay, let me say 2 on 1, because it's force 2, a charge Q2 on Q1. This charge what? Q3 on Q1. So that's why we write that 3, 1. Now, if you check the two forces now, you check it very well. This is what? The origin charge. We have one moving like this. The one going here is 3 on 1. Then we have another one up, which is what? 2 on 1. You understand me? So that is what is happening here. This is what? The charge at the origin, which is what? Minus 2 microcoulombs. The one that is caused by the one that caused this force, this 2 1 is what? Charge what? Plus 4 microcoulomb. The one that caused this one is what? Charge what? Minus 3 microcoulomb. That's the one that caused that one that was here before. That was here. So now we now know what is happening now in the what? At the charge placed at the origin. Now let us find what each of these forces. 2 1. It means what? K Q2 Q1 all divided by R21 squared. Now we are going to find the force. So between this charge and this charge, Q1 and Q2, what is distance apart? Is 10 centimeter. So I want to use 9 times 10 raised to power 9. What is Q2 now? Q2 is 4 times 10 raised to power minus 6. Absolute. What about Q1? Q1 is minus 2 times 10 raised to power minus 6. Absolute. Divide by what? What is our 10? The distance between Q2 and Q1 is 10, which is what? 0.1 square. If you divide by 100 to convert to meter. So this one is in meter now. Don't forget. Now, that will give us what? F21. Don't forget that you must take absolute of whatever you are doing. Now, let's look for F31. F31 is equal to what? 9 times 10 raised to the power 9. Absolute of what? This is F31. Okay, let me write it out so that you can understand. So this one is K Q3 absolute Q1 all over R31 square. So that's what we are using. So what you are going to do now is simply to just write the app. 9 times 10 to the power 9. Absolute of Q3 is what? Minus 3 times 10 to the power minus 6. Q1 is what? Still minus 2 times 10 to the power minus 6. Minus 6 because of microfarad. Microfarad. Micro is minus 6. Micro is minus 6. You should know that. Do not be telling you micro is what. So you convert the micro to coulombs. So you divide both sides by what? What is our distance apart between this Q1 and Q3, which is 3 1, is 15. So you divide by 100 to convert to meter, which is all square. So you get our value here. You get our value here. Now let's press our calculator to see how we can get this one done. So this one will give us what? 9 times 10 to the power 9. Then minus what? 12, because this is minus 12, this is 8. The minus will cancel out. So that's what will happen there. Then square of was 0.1. That's what we are doing now. We are going to have what? 7.2 Newton. Now let's find the other man there. So this one will give us what? 6. 3 times 2 is 6. Okay. So everything remains the same except that value. And the denominator is what? The distance apart is what? 0.15. If you divide by 100, 15 divided by 100. So this one will give us 2.4 Newton. Now, I haven't gotten the forces in their magnitude. So let's place them. This 1, 3 is 2.4 Newton. Then the one of 2, 1. 2, 1 is what? 7.7, 7.2 Newton. Then this is the what? The magnitude of the resultant. This is the total force. F total. And this will be the direction here. That is direction. So now, but don't forget, this is your what? Let me write it here. This is your positive what? X-axis. Don't forget, from our diagram, this is our positive X-axis. Okay, now, let's solve the total force first. The total force will now be equal to what? Also, if we use Pythagoras theorem, we have what? Fx is what? This Fy is there. So use Pythagoras theorem. This is 7.2 now. Newton. Y here is 2.4. This is 2.4 Newton. So if we want to use Pythagoras theorem, we have what? F squared equal to what? 7.2 squared plus 2.4 squared. To get the total force. What do we have? So we square both sides using Pythagoras theorem. Square the two sides. Hypotenuse square, opposite square equal to opposite square plus adjacent square. That's what we are using. Then what I would have is 7.58 everything. That means F is F total 589, which approximately was 7.6 Newton. So that's what I would have. You can confirm it by yourself also to see whether there's any error, which I believe there's no error. So if you solve it well, you are going to have that. Now, that is the magnitude. We have just solved to find the total force on the charge at 0. So this is total force now. So the total force is question A now. The total force is 7.6 Newton. Now let's go to question B. Say what? Find the magnitude of the total force in A above. Okay, we have looked for. Okay, this is total force. This is not the total. To find the total force, we can. This is B. Sorry. In this one is in magnitude. In magnitude. But this one now is like talking about in coordinate format. So which I'm going to write as the total force can be written as what? This one is going towards the negative I. While this one is going toward the positive J. That means positive Y direction. So I'm going to write it as what? This is what? 2.4 I plus what? Now, minus. You know why it's minus? Now it's moving towards negative what? X direction. So it's going to be minus. Why the one that is going towards the positive Y direction will be plus? Positive what? Positive Y will not be what? Plus 7.2 what? J in Newton. All in Newton. So that will be our answer, or A. This is A. It's 2.4. 2.4 Newton. Then 2.4 Newton. The F31. Then this is what? Question A. A is what? Total what? Force. That is A question there. So we have solved the A. This is A. Because in this case, first question, the answer must be in terms of what? Vector form. Because they said calculate the electric force. They did not say in magnitude. So that's why I just what? Believe that this is our correct answer, no doubt. So 2 minus 2.4i y negative because it's moving to the negative x direction. Then plus 7.2y plus because it's moving positive y direction. And I represent x unit vector to show direction on the x-axis. J represent what? Unit vector to show what? Direction on the y, unit vector of y to show direction on the y-axis. So that will give us your answer for A and B. Let's solve for C. Now C is the last one. I say find the what? The angle that the total what? Electric force makes with the what? With the x-axis. So we are looking for this angle here. The direction it makes with the x-axis. This is the angle that we are talking about. What angle does the total force make with the positive x direction? That is, this is what? The angle. But let us find this theta first, which is direction of this in its coordinate. It's in the second quadrant. So the force, the total force falls into what? The second quadrant. And that will give us what? Tan theta is equal to what? Force along the y, but force along the x. That is the formula we use to find direction there. C, which is what? What's our y direction? Y is what? 7.2. Even if you want to use SOHCAHTOA, this is opposite over adjacent. Tan to find theta, opposite over adjacent. This opposite, which is this, over adjacent, which is tan. So 7.2 Newton divided by 2.4 Newton equal to tan theta. So what do we have? I want to have it as what? 7.2 divided by 2.4. So tan inverse of what? So I would have 3. So theta will now be tan inverse of what? 3. Because that is 3. I would have 71.5 what? 71.565. Now, let's see, confirm it. 7.2 to be very clear. 2.4. So 71.565, which is about 72 approximately. If I want to say it's 72 degrees. Now, which is the direction from here to this place. Now, what about from the positive x direction? Now, if here is 72 degrees, this theta, what will be from here to this place? Angle on what? In a straight line is 180. So I will just say the what angle from the what positive x axis is equal to what? 180 minus what? 72. 180 minus 72 will give us 108. Can press your calculator degree to confirm. 108 what would be our answer there from the what? From the positive what? X axis. So we have answered. This is what? C now. The answer to C. This is answer to B, which is this one. And this is answer to what? To what? A. So see, when we shall see again to solve more problems, this time around in my next class, I'll be looking at problem questions when when 3 charges are placed in an what? In a parallelogram or in a triangular shape, an equilateral shape, in a what? Maybe in an isosceles triangular shape or equilateral triangular shape. Then what will happen? How do we calculate the force on one of the charge placed at the corner or at the apex of one of the what? Of the side or the corners of the equilateral triangle? That's what we're going to be looking at in our next class. But stay tuned on this channel by subscribing and click the notification button to get what involved anytime we post our videos. Thank you. God bless you.